Hello grade 10 students! Welcome back to my YouTube channel. Here I am again, Mr. Brian Bulactin at your service. Today, I will be making a tutorial video for Module 5 of Quarter 1, which is about arithmetic sequence versus geometric sequence. So you heard it, there's already a new kind of sequence. Let's find it out together. Okay, let's have this example of a sequence. 3, 8, 13, 18, and so on. So this is an infinite sequence. Now the question is the sequence arithmetic or not? Okay, so in this case, to answer the question, we need to get the differences between any two consecutive terms. And if there is common difference, then it is arithmetic. So let's have the first difference is equal to 8 minus 3 is 5. Second difference, you will have 13 minus 8, which is also equal to 5. Now, our third difference is 18 minus 13 is equal to 5. There is a common difference. There is a common difference, which is represented by small letter d. Therefore, we can say that this first example is an arithmetic sequence. So it is an arithmetic sequence. Now let's have another example. Let's have this too. Another infinite sequence. Let's find out if this sequence is also an arithmetic sequence. Let's solve for the first difference. 4 minus 2 is 2. Second difference will be 8 minus 4 is 4. Third difference is 16 minus 8 is equal to 8. Do we have a common difference? The answer is no. There is no common difference. Therefore, number 2 is not an arithmetic sequence. But let us try to observe the given. 2 becomes 4, 4 becomes 8, 8 becomes 16. What is the pattern that you notice? You are right. There is a constant multiplier of 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is equal to 16. It is not an arithmetic sequence, but this sequence is what we call geometric sequence. So this is another special type of sequence. We call it arithmetic sequence. So what is a geometric sequence? So what is a geometric sequence? It is a sequence that has a common ratio. So what is present here is common ratio. Common ratio represented by a small letter r. In arithmetic, we have common difference represented by small d. For geometric, we need to have a common ratio is represented by small letter r. So these are the important things that we have to remember. In arithmetic sequence, if the common difference is a positive number, we will be adding the common difference to the preceding terms. We will subtract if the common difference is negative. For the geometric sequence, we will multiply to get the succeeding terms if the common ratio is whole number. If the common ratio is a fraction, we will divide the preceding terms to get the succeeding terms. To strengthen your understanding on common ratio, let's have this task. Determine the common ratio R of the following geometric sequence. So it's already given that these two sequences are geometric sequences. And our major task is to find the common ratio. So to find the common ratio, you can choose any two consecutive terms of the sequence. So you can have this two, you can have this two, or you can have this two. Any two consecutive. So to solve for the common ratio, you will have R is equal to, choose any two. So you can have this. You can have 9 divided by, since we're talking about ratios, so it is division. 9 over 3. Because another representation of ratio is, you can have 9:3. If you'll say ratio can be presented in the following form. 9:3. You can have that. Or you can have, or another way of presenting it is in fractional form. 9/3. Or you can have 9 divided by 3. So any of these three forms is your way of presenting your ratio. So you can have 9 divided by 3 is 3. So our common ratio here is 3. Can you interchange the two? Can you have 3 divided by 9? 9 divided by 27? The answer is no. Just like in arithmetic, it should be present divided by the previous. Okay? In arithmetic, you will have subtraction. Here, in geometric, you'll have division. So 9 divided by 3 is 3. 27 divided by 9 is 3. 81 divided by 27 is 3. The common ratio is a whole number if the numbers are increasing. So 3 becomes 9, becomes 27, becomes 81. The trend is increasing. It is expected that the common ratio is a whole number. Okay? Now let's have example number 2. 125, 25, 5, 1. So to get the common ratio, just choose any two consecutive. So you can have this 2, you can have this 2, or you can have this 2. Okay? So you can have 25 over 125. Reduce, because it is reducible. Reducible by 25. 25 divided by 25 is 1 over 125 divided by 25 is 5. Okay, we will still get the same answer even if you choose these two other pairs. So R is equal to 5 over 25. Reduce. Reducible by 5. 5 divided by 5. 1 over 25 divided by 5 is 5. So 1/5. If you will choose the third pair, very easy. You'll just get immediately the common ratio. 1 over 5. So our common ratio is 1/5. And now to test if you have already a clear understanding of what geometric sequence is and what's the difference between arithmetic and geometric, let us have this task. Tell me whether the following is arithmetic, geometric, or neither, meaning not arithmetic, not geometric. So how are we going to do it? Let's have this example. 8, 16, 24, and 32, and so on. So, to be able to tell whether it's arithmetic, geometric, or not, or neither, you have to solve for the common difference or common ratio. So let's start with the common difference. Let's solve for d sub 1, if there is a common difference. So 16 minus 8 is equal to 8. D sub 2 is equal to 24 minus 16, and that is also equal to 8. d sub 3 is 32 minus 24, which is also equal to 8. There is a common difference d. Okay? Therefore, number 1 is an arithmetic sequence. That is how you'll do it. If in case there is no common difference, you proceed to getting the ratios. And if there is a common ratio, that is geometric. And if in case there is no common difference, there is no common ratio, that's the time that you can say neither. Okay? Let's have example number 2. 1,296, 216, 36, and 6. So, actually, if you already know if it's arithmetic or if it's geometric, by just looking at it, you may not solve anymore the ratios or the difference. But if you want to be systematic and if you want to do it one after the other, you want to take it slow, we can start with getting the common difference or getting the differences first. So you will have 216 minus 1,296, which is equal to negative. You have negative 0, 8, 0, 1. Negative 1,080. Then, the second difference is 36 minus 216 equals. That is negative 0, 11, so that is 8. Negative 180. Okay, you have negative 180. Obviously, the differences are not the same. So you may not continue for the third difference because it is obviously not an arithmetic sequence. So you proceed to the ratios. Perhaps number 2 is geometric. So let's have ratio number 1, 216 over 1,296. 1,296 is divisible by 216. So this is reducible by 216. 216 divided by 216 is 1 over 1,296 divided by 216 is 6. So that is our first ratio. Proceed to the second ratio. You have 36 divided by 216 is equal to 36 and 216 are both divisible by 36. So 36 divided by 36 is 1. Then 216 divided by 36 is 6. So the two ratios are the same. But you have to proceed to the third ratio because it might be misleading you. So the third ratio would be 6 over 36, which is both divisible by 6. So 6 divided by 6 is 1 over 36 divided by 6 is 6. Do we have a common ratio? The answer is yes. There is a common ratio of 1 over 6. Therefore, number 2 is a geometric sequence. Actually, you can already tell if it is arithmetic or geometric by just looking at the given. So you have noticed that number 1 examples, you have 8, 16, 24, and 32. There is a common difference. Therefore, we could not really expect a big leap of numbers, because we're just talking about common difference. In number 2, obviously, you notice that 1,296 becomes 216, becomes 36, and then becomes 6. The change in numbers is the differences between numbers is big. And if that's the case, obviously it's not really arithmetic. That's already giving you the idea that probably it is geometric. If the decrease or increase in numbers is fast, or the gaps are really big. Okay? And in number 2, you have noticed that the numbers are decreasing, therefore expect a fractional common ratio. Now let's proceed to number 3. The given is 1, 2, 3, 5, and 8. Let's start solving for the differences to find out if there is common. So you have 2 minus 1 is 1. Then the second difference would be 3 minus 2 is also equal to 1. So that's already giving you a hint that it could be arithmetic. But proceed to the third difference. 5 minus 3 is equal to 2. Then the fourth difference is 8 minus 5 is equal to 3. Obviously, it's not an arithmetic sequence. Okay? So proceed to the ratios. First ratio, 2 over 1. 2 divided by 1 is 2. Second ratio would be 3 divided by 2. 2 and 3 over 2 are not the same. Therefore, we don't have also a common ratio. So you may not proceed to the third and the fourth ratio. So it doesn't have a common difference. It doesn't have a common ratio also. Therefore, we can say that number 3 is not arithmetic. It's not also geometric. Therefore, your answer would be neither. That means it's neither arithmetic nor geometric. And there you have it, guys. Thank you very much for watching. I hope that I'm making things clear to you. I hope that I have differentiated clearly arithmetic from geometric sequence, and that I have explained geometric sequence well to you, because the succeeding lessons will be talking about geometric sequence. Again, for geometric sequence, there is a common ratio between two consecutive terms. So thank you once again for watching. Please watch, like, and share this video to your friends. And don't forget to subscribe so that you will be notified for more videos from my YouTube channel. Thank you very much. Goodbye.